Welcome back to DM Academy. Okay, let's have this addition of vectors, but this time we will use the component method to find the sum of all vectors or to find the resultant vectors. Okay, so given vector A is equal to 2 centimeters with an angle measurement or with a direction of 25 degrees. Vector B is 4 centimeters with a direction of 125 degrees. Vector C is 6 centimeters with a direction of 210 degrees, and vector D is equal to 8 centimeters with a direction of 320 degrees. Okay, so let us graph this first. Vectors. Let us graph this one by one. Okay, vector A, because of the 25-degree angle, vector A is located at the first quadrant. Okay, so this is the vector A. We will graph this as an ordinary vector in Cartesian plane. And this is 25 degrees. Okay, then vector B, 125 degrees, so it is located at the second quadrant. Then the angle is from here, from positive x up to here. Then vector C, 6 centimeters, that is at 210 degrees. Then the angle is from here, from positive x-axis up to here. That is 210 degrees. This is 6 centimeters. For vector B, this is 4 centimeters. For vector A, this is 2 centimeters. Then last, for vector D, that is 8 centimeters, 320 degrees. So it is located at the fourth quadrant. This is vector D. The 320 degrees is from the positive x-axis counterclockwise up to here. That's the 320 degrees. Okay, and the length of this is 8 centimeters. Okay, so after graphing the vectors, you need to solve the x and y component of each vector. Okay, so for x component, okay, for vector A, okay, for vector A, the x component of vector A, that is the magnitude of the vector A multiplied by the cosine theta, which is the theta is the angle formed by the vector A from the positive x-axis, and that is 25 degrees. I'm sorry, the magnitude will be 2 only, not 25. Okay, that is 2 cosine 25 degrees. Okay, and this is equal to 1.81. Okay, and for vector B, that is the magnitude of vector B, that is 4 centimeter, cosine an angle from the reference axis formed by the vector B, that is 125. So what is 4 times cosine 125? That is negative 2.30. Okay, then for vector C, the x component is the magnitude of vector c, that is 6 centimeter, cosine the angle formed by vector c from the reference axis, that is 210 degrees. So what is 6 cosine 210? That is negative 5.20. And for vector d, that is the magnitude of vector d, 8 centimeters, cosine of the angle formed by vector d from the positive x-axis, and that is 320 degrees. Okay, so 8 cosine 20, or 8 cosine 320. That is 6.13. Okay, then take the sum of this. Is the summation of r x sub x, that is equal to 0.44. Okay, next, compute this time the y component. Okay, let's start with vector a. This time we will use the sine function. That is the magnitude of vector a multiplied by the sine of 25 degrees. That is 0.845. Okay, for vector b, it is 4 sine 125 degrees. That is 3.28. Then for vector c, that is 6 sine 210. And that is negative 3. And for vector d, that is 8 sine 320. That is negative 5.14. Okay, then take the sum. This is the summation of ry. That is negative 4.02. Okay, let us solve again the x component. That is 1.81 minus 2.30 minus 5.20 plus 6.13. That is 0.44. Okay, next, you can calculate this time the magnitude of the vector r, and that is equal to r is equal to the square root of the summation of rx square plus the summation of ry square. Okay, and that is equal to 0.44 centimeter quantity square plus negative 4.02 quantity centimeter square. And this is equal to 4.04. Okay, that is only the magnitude of the vector r. Next is to compute the direction of R, which is the theta can be calculated by the arctan of the summation of Ry over the summation of Rx. And that is equal to the arctangent of negative 4.02 divided by 0.44. Okay, and that is negative 83.8 degrees. Negative 83.8 degrees. Okay, so therefore, our resultant vector is equal to 4.04 centimeter in magnitude with a direction of 83.8 degrees south of east. Okay, so vector R is somewhere here on the fourth quadrant. This is our R. Then the 83.8 degrees is below positive x-axis. So from here up to here, that is the 83.8 degrees. Okay. This is our resultant vector. See you on the next video. Thank you for watching.